Hello again. If you didn't grow tired of me yet, there is plenty of time to do so. Now we're going to talk about the energy evaluation of the different animals on the feed, because it would cause a great hazard if we had one kind of energy measurement in the animal and another one in the feed. So we're trying to synchronize the whole thing and take the hazard now instead. We're going to begin with the gross energy. The gross energy is the energy content that is existing in the feed. And what they do is that they burn it and they measure the heat that comes out when you burn it. And that way you can sort out what kind of energy you have in your feed. The problem is that if you burn a piece of wood and if you burn a carrot, you could get more or less the similar value. But obviously, if we would eat the carrot, we would get more energy out of that than if we ate a piece of wood. But in human nutrition, they say that we will not likely eat a piece of wood. In animal nutrition, this is not really clear all the time, that what would you eat and what you not would eat and so on. So there is differences, and this is when the hazard begin. So when you have your gross energy and you put the feed into an animal, you have something coming out in the other end, so the fecal energy, because there are things inside the feed that the animal will not digest. We talked about the fiber fractions last time, and the undigestible fibers are example of this. It's energy in the fibers, but we cannot use it. So animal species that will use the kind of energy that we get when we subtract the fecal energy, and by the way, that energy that we get is the digestible energy. So the energy that we will be able to digest is the things that are not fibers or things that we cannot digest. It's kind of simple. And we use this kind of expression in animals where we have large fiber fractions. So for example, the rabbit, or large fiber fractions that they cannot digest. So for example, the rabbit, the swine, and the equine. So basically all the monogastric animals that are on a high fiber diet use this kind of energy. The next step from this, since this is just an overview, is that you have the digestible energy, which was the gross energy minus the fecal energy, which is the undigestible things in the feed. You have left the metabolizable energy. And the metabolizable energy is, well, you have to subtract the urine and the gases to get the metabolizable energy. I hope that didn't confuse you. So the digestible energy minus the urine energy and the gas energy that we'll give. Everybody knows that if you eat something, you will probably produce gases as well. Now there is animals that produce more gases, and they produce gases in such amount that you need to take it in consideration when you do their energy evaluation. For example, ruminants are one of these. Now there is special, it's a bit depending on which country you live in. Now here, since we're in Hungary, the ruminants is evaluated by the net energy, and we're going to take that later because this is a second step. But the metabolisable energy is used primarily in carnivores. Since they have, especially cats, for example, they are strictly carnivores. They don't eat anything. They should not eat anything. I know a lot of cats that eat cakes and bread, but they should only eat meat. So all their energy comes from the meat, and there is a lot of energy in the nitrogen and the nitrogen bonds that are causing. Now the nitrogen is excreted by the kidneys. So this energy that was in the nitrogen is now not in the dog or the cat, but it's in the urine, where it's no use to have it. So we need to take that in consideration. It could also be good to mention on the exam that the fur-producing animals that we have, like the mink and the fox, is also carnivores, so it belongs to this group. And for the previous, you can mention the herbivorous fur animals like chinchilla for the digestible energy. Now to go back to the metabolizable energy, if you have the metabolizable energy and you take off the heat, you get the net energy. So the net energy is divided here into 3 different kinds of net energy. Now this is a little bit tricky. This is primarily used in ruminants, and especially since they are. I love cows. I want to specialize them, so this is a matter of heart for me. But the net energy for maintenance is they have a higher utilization rate. So if you give the cow a very poor feed, it will be able to utilize the energy better for maintenance because it's more important to stay alive. Now this is about 70 to 80%. So if you give the cow feed that contains 100 grams of energy, it will only be able to use about 70 or 80 grams of this energy. And this is for the survival of the cow. And also additionally for cows that are lactating 12 kilograms of milk, which is for a cow absolutely nothing. And then you have the net energy for lactation. And that is the second best utilization rate for this, because it's obviously very important to keep the calf alive as well. And this utilization efficiency is about 60-70%, if I'm not correct. I need to look at my notes. Yes, 60 to 70%. I remember correctly. Good. And this lines of, if you show a diagram, which could be the case, or if you will draw it yourself, the net energy for maintenance and the net energy for lactation will go almost parallel, so they will be like this. But then you have the last one, which is the net energy for gain. And the net energy for gain is a luxury thing that you don't really need unless you are a very, very young animal and you need to gain your developmental stages. But you need to add more energy because the body will only gain if it has good quality feed. So if you feed the animal a poor feed that's not easy digestible, that's bad quality, it will not gain, because the gain, net energy gain, has a utilization rate of approximately 30 to 50%. So if you give the cow 100 grams of energy again, it will only use 50 grams for its gain. Now, of course, all the feed that we have in our feedstuff table have three different kinds of energy. This does not mean that you add up all these 3 energies and that is the energy that you have. It means that the energy content, if the cow would use this feed for maintenance, is the value that stands under the net energy maintenance. But if it used the same feedstuff, but for its gain, it will be only 30% of the whole actual energy. So that value will be a much, much lower value. And if you look at your feedstuff, you'll probably see the tendency. But this is a whole other topic, which I'm going to go through later. So just to revise the whole thing again, quickly, you have the gross energy, the digestible energy, the metabolizable energy, and the net energy. And the net energy, you have the net energy for maintenance, for lactation, and for gain. Now, hopefully that was helpful, and see you next time, and good luck for your exam again.